And welcome back. So we're going to question 9 in the 2013 State Exam Commission exam. Reading the question carefully and looking at the picture, certainly remember this is one of the theorems on the course, and I've got something pretty nice to show you now in a moment. So we'll just read if three lines are parallel lines, and can you see that they've been marked as parallel already? Find these particular angles. Now I'm going to jump out and look at the theorems. So this is where I want you to concentrate on a way to study all the theorems in one place. The web address I'm looking at here is padlet.com or downs/t. Okay. And in this page I have all the theorems in one place. However, it's even better than that, because once we find a number for a theorem, we can add that. We can find it in here, and we can explore these what are called dynamic applets. But we can also just key in the number 11. So you see this one here? If three parallel lines cut off equal segments on some transversal, they will cut off equal segments on any other transversal. So I think that's the theorem we're looking for. So what I want to show you here is, yes, you could kind of, and I just click outside to get rid of that. They're the different things on your syllabus to tell us what we want to do. So we could move over here and find number 11 down here. However, you could just key in the number 11 after T. So T stands for theorem, and that will definitely give you theorem 11. Okay, so it'll be an uncluttered page with theorem 11 here. So click it, and let's have a look. Theorem 11. If three parallel lines cut off equal segments on some transversal line, then they will cut off equal segments on any transversal line. So basically, if that's equal to that, then that's equal to that. Now, okay, look, this is not equal to that, but there are some other points, and that is, so, okay, I'm going to confess I don't know what theorem it is, but that doesn't matter particularly right now, because I think this is quite easy. So we just have to use different theorems on the course to answer the question, and it's a kind of a leapfrog situation. So remember, get some answer right, and then from that, do some angle chasing. So we need alpha, beta, and gamma. They're the first three letters of the Greek alphabet. And if you're writing these, you write it like that. Write this one like a funny B with a little bit of a starting kind of lead in. And for gamma, most people will write it this way. And it's like A, B, and C in the English alphabet. Okay, so alpha is, be careful actually, alpha would be opposite that, so I don't know what alpha is. I know something corresponds to 115, and that's here. Because they're in corresponding places of where a transversal cuts across parallel lines. Quite tricky, isn't it? So I know this is 40. So what I'm doing is I'm writing in any information that I've discovered. Is there any other information given above? No. So let's be very honest, this is a difficult question. We may have to do a thing called a simultaneous equation. How about gamma here? So if I map that up, I get gamma here. So I'm afraid we might be looking at a simultaneous equation. That looks a bit like an 8. Let me change that to a gamma.